You ship a tiny customer support bot before bed. One large language model call looks cheap, maybe fractions of a cent. But the bot gets stuck. Search, summarize, search again, apologize, search again. Each turn stuffs the previous answer and a full tool result back into the next prompt. By morning, nothing dramatic happened. No server melted, no alert fired. You just bought 200 calls, each larger than the last, and the invoice makes no sense because you priced one call, not the loop. The beginner mistake is budgeting an AI feature like a normal web request. One request, one response, one rough price. That breaks because model calls are not billed per call. They are billed by tokens. Your prompt has tokens. The model response has tokens. Tool results you paste back into the conversation have tokens. Conversation history has tokens every time you resend it. And agents repeat. A harmless 5-cent test can become real money when it runs every minute, for every user, with 10 iterations per task. If you cannot count tokens, you cannot estimate cost, latency, or whether the model even has room to think. A token is the unit a model reads and writes. It is not exactly a word. For English text, a useful beginner estimate is 1 token for roughly 3 to 4 characters, or about 3/4 of a word. The exact tokenizer depends on the model, but the budgeting idea is the same. Everything is metered in tokens. System instructions, user messages, examples, retrieve documents, tool call arguments, tool results, and final answers. Providers usually price input tokens and output tokens separately, and output tokens often cost several times more because generation is more expensive than reading. The application programming interface response includes usage numbers. Treat those numbers like logs, not trivia. Here is the basic shape I use before any agent loop. First, estimate tokens before sending the call. In Python, a rough function can return length divided by 4. Later, replace it with the tokenizer for your chosen model. Second, write a price function with 3 counters: input tokens, output tokens, and tool result tokens. Some providers bill tool results as input when you send them back, but keep a separate internal counter so you can see which tool is making prompts fat. Third, after every call, read the SDK usage object. Prompt or input tokens, completion or output tokens, and total tokens. Fourth, multiply the per call estimate by the maximum number of iterations. Suppose you build an email drafting assistant. The system message, user request, and formatting roles are 900 input tokens. It calls a local search tool and gets back 2,400 tokens of notes. The model writes a 500 token draft. If input costs 1 unit and output costs 4 units, that call is not just 3,800 tokens. The output is weighted more heavily. Your rough cost units are 900 input, plus 2,400 cool result tokens that become input on the next turn, plus 500 times 4 for output. Now let the agent revise 6 times. The real estimate is not 1 call, it is that per turn shape times 6, plus growing history, unless you trim it. 3 traps matter. First, chat history is usually resent on every call. If you keep appending everything, turn 10 can be much more expensive than turn 1. Second, tool output is often the hidden killer. A database row, a web page, or a long stack trace may be cheap to fetch, then expensive to paste into the model. Third, max output tokens is only a ceiling. It protects you from extremely long answers, but it does not make the prompt small, and it does not guarantee quality. Also, sheet models do not save a bad loop. A low price per million tokens still becomes painful when your harness has no iteration limit. Tokens connect directly to the rest of this series. Prompt engineering is partly token budgeting. What instructions are in space and what can be removed. Context windows are token limits, not document limits. Tool calling is token design because every tool result needs a shape, a length, and a reason to be included. Memory is dangerous if it means dragging old text forever. And the agent harness needs hard limits: maximum turns, maximum tool bytes, maximum output tokens, and a stop condition. Once you see tokens as the shared unit, cost, latency, and reliability, stop feeling like separate mysteries. Try this locally with no third-party target and no production data. Create 3 strings: a system instruction, a user request, and a fake tool result. Maybe a pasted paragraph from your own notes. Write estimate tokens by dividing character length by 4. Print estimated input tokens before the call. If you make a real model call, read the returned usage fields from your SDK and print them next to your estimate. Then simulate an agent by adding the answer and tool result back into the next prompt 8 times. You do not need the model for the simulation. Watch the input token count grow, then multiply by your provider's published input and output prices. Recap. 1. Tokens are what you are actually paying for, and a rough beginner estimate is 1 token per 3 to 4 characters. 2. Input, output, and tool result tokens need separate accounting, even when the provider reports tool results as input later. Output tokens usually cost more, so long answers are not free. 3. Agents multiply token cost by iterations, so always budget the loop, not the demo call. Tomorrow we connect this to context windows, why models forget, truncate, or drown in too much text. New Agent Foundations episode daily. The paid libraries at aislabs.ai go deeper.